Okay, getting to the trickier questions now. We've got the time period of pendulum on Earth is 1 second. So here's a pendulum on the Earth with a time period t equals 1.0 seconds. And we're asked what's going to be the time period of the pendulum of the same length, so exactly the same length pendulum, on another planet, which we'll call P, for no exciting reasons at all. And we don't know what the time period of this thing is, but that's what we're trying to work out. But what we are told is the planet has half the density, but twice the radius of the Earth. So this one here has got the density of Earth, which we'll call just ρ, and it's got the radius of Earth, which we'll call r. The density of this planet, we said, was half the density, so it's going to be ρ/2. The radius is twice as big, so we're going to have a radius of 2r. So we need to find out how these factors come together to affect the time period. Now the time period of the pendulum, we're going to write it up here just for reasons of space. We've got a fairly straightforward equation of the time period. It's going to be 2 pi root L over G. Again, given to you in your formula booklet. Easy to understand, not easy to write clearly. So t equals 2 pi root L over G, and the nice thing is that we're told that the length of the pendulum is exactly the same. So that's not going to have any effect. All we want to do really is find out what's happened to the value of G. How is G different on planet P compared to planet Earth? Well, we can basically work that question out by looking at how the factors come together to give us the surface gravity. So we've got an equation for surface gravity. We bring it over here, so we know that it's going to be G is gm over r squared. So that's our equation usually. G is gm over r squared. So I want to know, on my planet, planet P, how is my mass affected and how is my radius affected? Well, let's start first of all by saying on planet P I know the radius of my planet has doubled. So we'll first of all look at this factor here. When I double the radius, what happens to this thing? Well, obviously this is going to become 2r all squared, but the mass is also going to change because I've got a much larger planet. My planet has got twice as big. So it's twice as wide, and it's twice as deep, if you like, and twice as high. So the volume of this is actually going to be 8 times as big. And we're ignoring the density change for the moment. We're going to bring that in a minute. If I simply take a planet and increase its volume by a factor of 8 without changing its density, then the mass is going to change by a factor of 8. So the fact that I've made this 2r now, this is going to become 8 times as big, and this, well, if we've got 2r and we're squaring the whole thing, it's going to be 4 times as big. So it's like multiplying this side by 8, and this side is now 4 times as big. So the overall effect of the whole thing is that the gravity, just from changing the radius at the moment, the gravity on planet P is going to be twice the gravity on Earth. Okay, now we said that we were putting aside the density for the moment, and that's going to be quite an important one. So let's bring the density back into here. I've already worked out that the factors just relating to the radius are going to give me a gravity twice as big, but my density is halved. Now my density doesn't affect the radius at all, it doesn't affect G of course, because G is a constant. It will only affect the mass. If the density is half as big, then the mass will be half as big. So the factor coming from the density alone, is it's going to give me half of the original gravity. So I've got two factors here. This one here is going to double my gravity, this one here is going to halve it. The overall effect, of course, is that those two things are going to completely cancel out, and my planet, with half the density and twice the radius, will have exactly the same value of surface gravity. So my surface gravity hasn't changed, my length hasn't changed, and therefore my time period will not change either. It is also going to be 1.0 seconds, which is answer B for question 8.